The James Webb Space Telescope, JWST, has opened up a new chapter in our understanding of the cosmos. In fact, there's no turning back now, as it has discovered a primordial galaxy as old as the universe itself. This discovery heralds the definitive end of old astrophysical and cosmological paradigms. We are at the dawn of a completely new natural science that may change the foundations of physics forever. If the data is correct, this galaxy appears to be far older than the universe. This shocking revelation suggests that our previous understanding of space and time must be completely reconsidered. However, the question remains, are we truly prepared to rewrite the history of the cosmos and expand the boundaries of our knowledge? The revolution underway in science is simply breathtaking. A revolutionary telescope is now showing us images of galaxies so ancient that they defy everything we thought we knew. The reach of the James Webb Space Telescope is finally revealing the first galaxies that existed shortly after the Big Bang. However, these galaxies are so far developed that their formation must have occurred before the Big Bang itself. This cannot be the case because, according to current understanding, either the Big Bang occurred 13.8 billion years ago and there was nothing before it, or there was no Big Bang at all. This paradox is forcing scientists to consider new explanations for the existence of these old galaxies. But if the Big Bang didn't happen the way we thought, what does this mean for our understanding of the beginning of the universe? Since NASA released the first deep field image from Webb, the headlines have been relentless. First, a team led by a young Harvard astronomer, Rohan Naidu, discovered a galaxy known as Galaxies Z13, with a redshift of approximately 13. This galaxy existed roughly 300 million years after the Big Bang. The name GLASS comes from the GRISM Lens Amplified Survey from Space, an international astronomy project that aims to identify the universe's oldest galaxies. The project initially relied on gravitational lensing but now benefits from the latest data provided by JWST. The data from Galaxies Z13 initially sparked skepticism among the international research community. However, the possibility of a measurement error can largely be ruled out. Galaxies Z13 certainly existed 13.4 billion light-years ago. It is one of the brightest galaxies ever discovered at such an early stage in the universe's history, showing signs of intense star formation. It may contain many young, massive stars that belong to population 3, which were the very first stars in the universe. These stars were enormous, extremely bright, and short-lived. Thanks to JWST's unique spectrometer, the telescope can break down even the faintest light signals into individual frequencies. This enables the analysis of the metallicity of distant galaxies, and Galaxies Z13 revealed something strange. Its spectrometer analysis indicated a low metallicity, suggesting a low proportion of heavy elements. This means that this galaxy shows signs of being young, yet it also has an unusually structured and luminous shape, which, according to previous models, suggests it should be several billion years old. According to this model, its formation would have occurred before the Big Bang. The scientific community could have written off Galaxies Z13 as a rare anomaly, but that seems unlikely, as more discoveries quickly followed. Shortly after Galaxies Z13, another galaxy was confirmed, Macy's Galaxy, and it is even older. Macy's Galaxy was discovered by astronomer Stephen Finkelstein, who named it after his daughter Macy as a birthday gift. The age of this galaxy has been confirmed by multiple testing procedures, and it too existed 300 or possibly even 270 million years after the Big Bang. Much like Galaxies Z13, Macy's Galaxy also shows high rates of star formation and low metallicity, suggesting it's young. However, its degree of organization is such that its formation would also date back to before the Big Bang. Around 300 million years after the Big Bang, the first stars should only have just begun to illuminate the universe, forming loose star clusters and protogalaxies. In theory, fully formed galaxies with hundreds of thousands or millions of stars shouldn't have existed at that time, yet both Galaxies Z13 and Macy's Galaxy challenge this idea. Finkelstein and his team have discovered numerous other galaxy candidates. At least 10 additional ancient galaxies have been confirmed. Finkelstein remarked in an interview that the first deep field image likely shows hundreds of these galaxies, though it will take time to confirm these findings definitively. However, the evidence is mounting that nothing in the young universe was as researchers once thought. And now, the JWST has made another astonishing discovery, one that may revolutionize astronomy as we know it. JWST has confirmed the existence of stars powered by dark matter. Since JWST's early discoveries, scientists have been scrambling for new answers. How can we reconcile these findings with existing theories? Did the Big Bang never happen? Was it earlier than we thought? Or did galaxies and stars evolve much more rapidly and in a completely different manner than previously believed? Any new explanation must somehow align with the foundations of astrophysics, but that's where many experts believe the real challenge lies. There's a growing belief that some of our fundamental assumptions about physics may be incorrect. JWST has recently discovered 3 potential dark stars from the universe's earliest epochs. This marks the first observational evidence that such objects truly exist. Dark stars are theorized to be powered not by nuclear fusion, like normal stars, but by dark matter. First proposed about 15 years ago, dark stars are believed to have existed roughly 300 million years after the Big Bang. Instead of generating energy through the fusion of hydrogen into helium, dark stars are powered by the annihilation of dark matter particles. Dark matter, which comprises approximately 27% of the universe's mass, cannot be directly observed because it neither emits nor absorbs electromagnetic radiation. Its existence has only been inferred through its gravitational effects on visible matter. If dark stars truly exist, this would provide indirect evidence for dark matter, allowing scientists to further investigate its properties. Dark stars are thought to be significantly larger and brighter than normal stars of the same age, with luminosities up to 10,000 times greater. They could have played a critical role in reionizing the universe and may have been the first sources of light after the cosmic dark ages. If dark stars were indeed the first celestial objects to light up the universe, they could be the key to understanding the impossible galaxies revealed by Webb. As we continue to uncover new cosmic phenomena, some forgotten scientific theories are once again coming to the fore. The work of 20th-century physicists Fritz Zwicky and Paul Dirac, for example, has found renewed relevance thanks to Webb's discoveries. Zwicky, known for his work on dark matter, also proposed a lesser-known theory called tired light, which suggested that light gradually loses energy as it travels through the universe, causing a redshift. According to this theory, the redshift observed in distant galaxies may not be due to the expansion of the universe but rather the gradual fatigue of light over time. If Zwicky's theory of tired light is correct, it would mean that the idea of an expanding universe could be an observational error. This would fundamentally alter our understanding of the cosmos, including the age of the universe and the formation timelines of galaxies. Paul Dirac, another contemporary of Zwicky, researched quantum mechanics and developed the Dirac equation, which predicted the existence of antimatter. Dirac also speculated that the constants of nature might not be as constant as we assume, they could change over cosmic history. Although Dirac's ideas were not widely accepted in his time, today's scientific landscape has changed dramatically. As more inconsistencies emerge in cosmology, the notion that physical laws might evolve over time is gaining traction. This concept could help explain some of the anomalies observed in the cosmic microwave background radiation, as well as the distant galaxies that seem to defy current models of cosmic evolution. Canadian researcher Rendra Gupta was among the first to revisit Zwicky and Dirac's old theories. By combining them, Gupta has recalculated the age of the universe, suggesting it could be 26.7 billion years old. In a second variant of this calculation, the universe could be as much as 40 billion years old, or even older. If Gupta's findings are correct, we may never be able to see all the way back to the universe's true beginning. Our technologies might continue to improve, but fundamental principles of physics suggest there could be a limit to how far back we can observe. In any case, we are at the brink of understanding how the universe truly began and how it functions. The ultimate key may lie in discovering the so-called God formula, the unified field theory that would explain all forces and phenomena in the universe. Until then, every new discovery from the JWST brings us closer to the answers, and each step shakes the foundations of what we thought we knew about the cosmos. The discoveries from the James Webb Space Telescope are reshaping our understanding of the universe. Stay tuned as we continue exploring the mysteries of space. Don't forget to like, subscribe, and hit the notification bell for more exciting updates.